All right, welcome everyone to NeuroHackademy Day 2. This morning we have Russ Poldrack back to talk to us about AI-assisted coding. We don't actually address AI-assisted coding directly all that much in this course, you might have noticed. Part of that is because this course was conceived before large language models really became a thing. Russ has been giving this talk at NeuroHackademy for several years now. And it's one of my favorites, partly because every year it has to change a whole lot, at least slightly. So without further ado, we'll give it over to Russ.
Cool, thanks. All right, I'll share the slides in the Zoom when we're done, but if you want to see them, you can get them through this QR code. So I have a question for you to start with, which is why do we need code? Like you're here to learn stuff about coding. Like why do we need code? Why is code useful? Anybody want to volunteer? Thoughts? I know it's early for audience participation, but thoughts about why we need code?
Create a pipeline, look it out pipeline.
Create analysis pipelines. Okay. So to solve problems for us, why do we need code for that? Why can't we solve them without code?
Doable.
We want to make it reproducible, right? Yeah.
Communicate with your computer.
You do have a computer, so it can happen fast, right? So we have problems we want to solve. Sorry, did you have a?
Automate our analyses, or else we're going to be clicking through hundreds of buttons for hundreds of participants.
Right. So to do things we couldn't do with our kind of human labor in a reasonable amount of time, right? And so if you look back at where coding came from, it's sort of interesting how it's evolved. My mom, when she was like in the early 1960s, she was involved in computerizing stuff at a bank, and the computers like had these like punch cards. And so then, putting your programming was like making holes in a piece of paper and sticking a stack of those into the computer and having it do stuff. And then in kind of, the 60s, 70s, 80s, people started to program in things like this, which is assembly language for an IBM PC. This was like the PC that was around when I was in high school. And like this was not a fun way to program. Like I didn't really learn to do this because it just seemed like a real pain because you had to like tell it where to put things in particular places in memory. And then these languages like this thing BASIC, this was the first programming language I learned. That was the first computer we had in my house in like the early 1980s, the Texas Instruments 99.4A, which you could put in like little cartridges to play games, or you could turn it on and it would go into this console where you could start programming in this language called BASIC that looked like this. Of course, that's nobody's heard of BASIC anymore, pretty much. And so in the last few years, suddenly you don't have to type code anymore. You can kind of ask questions in English. So let's say I want to know how, Rust is kind of a hot new programming language. I don't know how do you do a hello world program in Rust? I just go to ChatGPT and ask it, right? And this led a couple of years ago. Many of you may have heard of Andrej Karpathy, who had this famous tweet: "The hottest new programming language is English." And now, obviously, we don't even really have to, do much at all. We go to our agent and say, write a hello program in Python, and it will go do it for us and spit out an answer in a couple minutes. And then we can go run the thing. Actually, I guess I'll come back to asking you in a bit, like how many of you actually use these things, but that you can see that actually works. And so, like last year, people started talking about this idea of vibe coding, where you didn't actually have to know anything about coding to like create software that could do stuff, right? And so the idea was that was like the pinnacle of computer programming. And so also kind of last year, you would see a bunch of videos about how coding is dead, right? AI agents just killed coding. And coding may or may not be dead. Computer programming is not dead for sure. And I'm going to try to convince you that those are different things and that at least one of them is really important. But I also want to convince you that I think coding is not dead because people are realizing now that like vibe coding has bit them in the rear end. Some of you may have heard of it's like every week another like big blunder comes out where basically people inside a company relied on AI to do something that really should have had some human oversight. this, the most recent Instagram one, right? Basically people realized that they had made this mistake where they let the AI coding agents do security stuff, and suddenly anybody could go into the Meta AI tool and say, "Hey, I'd like to change the password on my account, which is Barack Obama on Instagram. Can you like give me the password?" And it'll say, "Sure, yeah, here's a new password." Or like this is a good one, right? That Ford had basically fired hundreds of veteran engineers, and then realized, hey, we actually need them back because the AI tools can't actually do what we thought they could. Or, these kind of like weekly, this is actually from last year, like, AI coding tool fabricates 100 users and lies to cover its tracks. Now this is interesting. Everybody thinks that like coding jobs are going away, but this is from this true up site that actually measures the number of jobs that are around, and it's actually interesting that you know basically companies hired a ton of people around COVID, and so they stopped hiring engineers around COVID, and actually those jobs have been going up even in the face of Claude and like the most powerful new tools. So code, like if this is revealed preference of companies, coding is not going away, right? They're still hiring people to do the stuff. And so I want to convince you that programming is not the same as coding. I mentioned Clean Code yesterday. It's a book by this guy Bob Martin, and this is a quote from him. And he's rewritten. This is from the previous edition. He's rewritten an edition now that's kind of more AI focused, but he basically says the same thing. And this is he's quoting people saying a decade ago that we're near the end of code because of a decade ago you had some kind of slightly automated tools that were nowhere as good as LLMs. Nonsense. We'll never be rid of code because code represents the details of the requirements. Specifying requirements in such detail that a machine can execute them is programming, right? So you have a problem. When you program, what you do is you come up with a description of that problem that's precise enough that the computer can solve it. And it used to be the case that programming languages were the medium by which you did that specification. Now you can start doing that specification in English or other natural languages. And specifications matter. So my wife and I are like serial home renovators, and she's an interior designer. So we think a lot about like, how do you decide what to do if you want to go like renovate your kitchen, right? So you could just say, well, put the island over there, 3 feet across the stove, put the pantry down at one end, put it next to the refrigerator. And then you get things like this, right? Where the door hits the sprinkler, or the doors hit each other, or the doors hit each other, right? Things just don't fit, right? Whereas if you actually plan things out and come up with specifications, you can, and this was our kitchen in Austin, you can come up with a really nice place, right? But it takes planning up front to make sure that everything kind of fits together. So as some of you said to my initial question, computers are here. Like the only reason we really want computers is to solve problems for us. And programming is the art of specifying the problem so that a computer can solve it successfully. And I'll talk a bit more about kind of how this relates to what LLMs are doing for us. Right now, it's evolved over time to be more natural language like, and now is you can program in natural language to some degree. That's what we're doing when we prompt an LLM or an agent to make code for us. I'm not going to say anything about large language models. Some of the details about how large language models work are actually really important and useful for understanding how to make LLMs do a good job of coding. I'll show a little bit of this. I'm going to mention, I mentioned my book yesterday. The book has a bunch of material about how LLMs work and why and how that's relevant. The other thing that I'll say is that there's a chapter on AI coding tools in the book, and at the top it says this chapter is under revision. That'll be the third time I've rewritten that chapter in a little over a year because of how fast things are changing. And this is a talk that I haven't completely rewritten, but it's substantially different in a lot of ways from what I did even last year. So, coding is, LLMs are good for lots of things, right? They're also can be problematic in ways that I'll show you. But coding is kind of an optimal use case, right? Because you can think of LLMs as being really useful when the content is kind of relatively difficult to generate, but relatively easy to verify, right? And code turns out to be, writing code to solve problems takes people a lot of time, takes LLMs a lot less time. And in general, it's not easy to perfectly verify it, but it's easy to verify it to a whatever standard you want to verify it to, because code can be automatically tested. And we'll talk about testing later on. And this is, I mentioned my book, bettercode-book.org, which has, a bunch of stuff. And the chapter on software testing comes before the chapter on coding with AI for exactly this reason, because I don't think you can do a good job of writing code with AI if you don't understand how to test that code to make sure it's doing what you want it to do. It's also a dangerous use case for LLMs because they're really good at giving you stuff that looks like real code and works. But the prompts that we give them are often not going to be sufficiently detailed to fully specify the problem, right? That's why we have code, because it allows us to be very precise. And so what happens when you do that? Well, the model is going to use its background knowledge, which is based on, like a ton of code that it read from GitHub, basically, amongst other places. And it's going to fill in the blanks. It's going to basically, if it doesn't, you're going to say something in English, and there's going to be a lot of details that it doesn't have. It's going to fill in those blanks with its assumptions based on what it has learned. And I'm going to show you examples of how that can go astray and why we need to think about verification and validation all the time. So this is a fun example that's several years old now, and I'm gonna try to put dates when I say stuff, and I'll tell you why. So this is a few years ago. If you went to ChatGPT and said, "Who is Wayne Poldrack?" That's Wayne Poldrack's my dad. He's a small town accountant from Texas. It would say Wayne Poldrack's a prominent neuroscientist who's known for his work in the field of cognitive neuroscience. And if you ask it, what awards has Wayne Poldrack won? It would give you a bunch of awards. A couple of these are things that I've won. The ones with the red X's are things that I have not won. And I think at least one of these doesn't actually exist. One of my grad students found this really fun hallucination, which Lindy asked ChatGPT, is Russell Poldrack a different person? And it said, I think you meant to say Russell with two L's. It's actually the same person as Wayne Poldrack. Russell is his middle name, and he often goes by Wayne rather than Russell. So basically, ChatGPT was saying that I am my father. So now, as of earlier this year, if you went, this is going to Gemini 3, if you went to it and said, "Who is Wayne Poldrack?" It said he's a retired CPA based in Rosenberg, Texas, and father of Russ Poldrack. While he's a private citizen, his name has become a topic of interest due to recurring AI hallucination. So Russell Poldrack has written about this area, using it as a case study to demonstrate how AI models can confidently present false. So it saw my book, which talks about this hallucination in the most recent, training, and now, or it saw the video of me probably at NeuroHackademy, and it now knows about that. So this is why I say, whenever you're going to make any generalization about large language model. I mean, large language models really don't hallucinate that much anymore. One place where they really do still hallucinate is academic references, citations. They still, I just saw one a few days ago by Claude 4.8 made up hallucination of a reference. But anytime you say AI models can or can't, especially anytime you say they can't do X or they do this thing wrong, you need to say when you found that, because things are still changing so fast that you can't really, I've heard a fellow faculty member say, "Oh, the kind of work that I do could never be done by a large language model." I'm like, "How do you know that?" "Well, I tried ChatGPT a few years ago and it couldn't do it." It's like, you have no idea what you're talking about, right? Unless you've tested things on the most recent models, because the frontier is moving so fast. Okay, so here's the one kind of feature of large language models that I'm going to talk about that's kind of relevant to AI coding. And so what the companies do before they give you large language models, they spend a bunch of time training it to predict the next thing in the text, right? But when you go use a language model, let's say you go start having a conversation with it, it kind of remembers the things that happened earlier in the conversation, right? But the model itself is not changing. The weights inside the model aren't changing. This is something we call in-context learning, where it basically has, which you can think of as like a big working memory buffer. It's holding all that stuff in working memory, and then the stuff that it generates going forward kind of uses that earlier information to condition what it's going to predict. So it's like combining all the stuff that it learned during its training with all the stuff that's in its little kind of, we call the context window. And those are put together to then predict the next step. And so this means that when you want the model to do something that it doesn't already know how to do or it doesn't understand, you have to make sure that the right information is in the context window. Here's an example. So this is like 10, I had a thing automatically generate this. 10 times I did this thing where it said, generate a Python function to compute a multiple linear regression solution using linear algebra. And this is just showing you the first line of the function, the function definition. And you can see that they all pretty much look the same, right? But this one has a slightly different name, but they all have something about linear regression and they have X and Y. So it kind of knows what that should look like. This is what happens if you give it the same prompt, but first you ask it, why are type hints important for creating a Python function? Type hints are these things that basically say, what kind of variables are these that are going in and what kind of variable is the function returning? I didn't tell it create Python functions with type hints. I just asked it earlier in the chat, why are type hints important? But because there's something about type hints in the context window, now almost all of its outputs, except for this one, include type hints. And interestingly, there's a lot more variability in them, right? They're not as consistent as they were before. So this is just an example about how understanding a little bit about how these models work can be really helpful in thinking about, why they behave like they do and how to get them to behave in the ways that you want them to behave. Okay, so I just want to do a kind of a show of hands. So how many of you have used like a chat bot like ChatGPT or something like that to create code and then copy and paste it? Raise your hand. Okay, cool. How many of you have used a coding agent like Claude Code or Codex? How many of you have used an editor that like does auto completion, like fills things in for you as you're editing the code? Okay, so most of you, a lot of you have had experience with a lot of these different ways of creating code. So I'm going to talk about some of the different interaction patterns, right? And I'll mention one that probably a few of you have dealt with. So what most people have done is what you might call single turn prompting, right? You go in and say, write a module to implement this thing, right? And this is Claude, it will go in and say, hey, yeah, I'm going to implement that thing. And then it'll save out a Python file that you can open in Visual Studio Code. That's kind of the way that most people start. The second is what you might call context-aware auto generation. So this is, I'm not typing anything here, right? All I did was type that comment at the top, implement the model, and I'm just tab completing now, and the model is auto completing just based on that prompt. So this is another way that many people get started. This is actually, I think, the way that I probably got started because a few years ago when GitHub first came out with their Copilot tool, you were using like Visual Studio Code, it would just do it, and it was pretty cool. Kind of felt like your mind was being read. So one way has anybody used like API access to actually generate code? Okay. So this is a less common way, but so for example, the thing I showed you earlier with the 10 examples, like, I didn't want to go through and type, have it like prompt it 10 times, right? And have to like, create a new chat window because it's really important if you're trying to test these things, you're not using the same chat session because it'll remember all the stuff that's come before. So for these types of things, you need to start a new chat session each time. So you can do this with code. If you just say, go in and say, hey, I need to prompt a model, create some code to do that. It's pretty easy to do that. You just have to give it a key so that it knows how to charge you for the tokens you're using. But then it'll basically spit back Python code formatted in a way that you can then go automatically run it. Now, those are all forms of what people have come to call generative AI, right? The AI takes a prompt and then gives you back a response from that prompt. Within the last couple of years, the field has moved to what's come to be called agentic AI, where the large language model isn't just generating things. It also has the ability to call tools that and use those tools to do other stuff. And these are what we call agents. So if you use Claude Code or Codex or Cursor, those we call them agent harnesses. They're not just a large language model. They're a large language model plus a bunch of other tools that the model can call, or agents that can call large language models that can call you. Can have sort of a whole hierarchy of different agents. And things like outside of coding, these have become well known in things like Claude Cowork or OpenClaw. Right, so here is, Claude Code doing the Python module thing. Claude Code is generally going to take quite a bit longer to do the thing, especially if you have it set up in a way that it's trying to do things well. Claude Code also spends a lot of time asking you if you give it permission to do things, which is a good thing, but at some point you just start saying yes, accept. So the ability of the models to solve coding problems has like risen in this like really like amazing way. So this is data from Meter, which is a nonprofit in San Francisco that's doing a bunch of work on kind of AI safety and monitoring. And so they came up with, there's a bunch of benchmarks around to say how good are the models at solving coding problems. The problem with benchmarks that are like, 0 to 100 is the models pretty quickly get up to 100. They kind of saturate the benchmark. So they came up with a different kind of benchmark, which is called task completion time horizon. And the idea is that they had humans solve a bunch of coding problems, and they looked at how long does the average expert human coder take to solve that problem. And so they have some problems that would take a human 3 minutes, some problems that would take a human 5 hours. They have a range of these problems. And then they basically say, okay, those are private problems, so the models don't know about them. They haven't been in the training data. Now they give them to the models and say, how good is the model at solving these different problems? And basically how long is the task that the models can get? In this case, this is the 80%. So what is the length of a problem that it takes a human to solve where the models can get it right the first try 80% of the time? And you can see that, starting out early on, GPT-3, GPT-4, they could get something that takes like a couple of minutes, 80% of the time. Now, the most recent like Claudes and Geminis could get something in an hour and a half. This is Mythos, which is you heard of Fable, which is the newest Claude model. Fable is like a version of Mythos. That's just like off the charts, can solve problems that would take humans hours with 80% success. And if you quantify how quickly have the models doubled their capacity, right? How many, and they quantify it in terms of days, like what's the doubling time? If you look over since 2024, basically since here through here, and this doesn't include Mythos. This is only through like these over here up through Opus and Gemini. They've been getting twice as good about every 100 days. Right, which really makes you kind of feel like you're on this treadmill where you have to relearn everything every little while because things are just moving so fast. It's really crazy. So I'm going to start by telling you about some work that we did actually back in 2023, which it's crazy how that seems like decades ago, and it was 3 years ago. Basically, we wanted to test how good. When GPT-4 came out, which was the first really good model for coding, we wanted to test how good it was at some like data science type problems. So we came up with a bunch of problems. Initially, we came up with problems by hand, and basically gave them to ChatGPT and said, "Hey, can you give me code to solve this problem?" And here it wasn't an automated benchmark. It was basically me looking at its solution and working with it to try to get it to solve the problem, and then deciding at some point that it had or had not solved the problem, which basically meant that I couldn't get it to give me a solution within a few minutes of effort. And what we saw was that about a third of the time it got it on the first shot. Another third or so it got it after a number of initial prompts, and then a little less than a third of the time I gave up before it solved it. Now we've since taken the same problems and run them through models in 2025 and earlier this year with Opus 4.6. And last year it kind of got most of them, 29 out of 32. Earlier this year it got all of them. And the problems are on GitHub, but the solutions aren't there. So it's not exactly like we've told it the solution, but it probably knows the problems at least. But it did take a significant amount of back and forth and thinking time for some of the problems to actually get Claude to solve them correctly. So it didn't just get them in one shot. So it kind of goes back to the point I made earlier that it's really hard to come up with like generalizations that are projectable that actually can extend out in the future about these tools, right? Because the frontier is moving so quickly. So if you're going to use the tools, you really have to kind of watch what's happening and kind of check in every few months to see kind of where things are. Okay, so what are some principles of reliable AI assisted coding? So like I said, I'm rewriting my chapter on AI assisted coding, and this overlaps somewhat with what I'm talking about there. I'm going to be spending a lot more time there talking about trust and like ultimately we need to figure out how can we trust the outputs of these models for scientific purposes, right? Because when we write a paper, we're vouching for the code the results that were created using the code that was generated by the models. That material is still in flux, and so I haven't added a lot of that in, but that will be developing. So if you watch the book over the next few months, I'll be putting that out. But I'm going to talk about a number of other sort of principles that I think are true now. They may or may not be true a year or two from now because they might be superseded by what the models are doing. But I think a lot of them are going to remain true for a while. And probably the main one is verification. How do you make sure that the thing is actually doing things correctly? So here's an example where I had GPT-4 create a Python function to do multiple linear regression. You saw example of this earlier. This is just two of the actual functions that it created, done in two separate chats. And each of these doesn't really do it fully correctly, or at least it has failure modes. The one on the top basically will fail in a certain condition, which is if the X, which is the kind of the model design matrix, if it already has an intercept in it, like a column of ones, this one's going to fail because it's adding a column of ones without checking. And so if it already exists, there's going to be two of them, and it's going to fail with a singular matrix. This one fails if you haven't included an intercept already, because it doesn't include an intercept. And so if you don't include an intercept, it's going to give you the wrong answer, because you have to have, as we saw in my talk yesterday, you have to have an intercept in your regression. When I went in and wrote tests for these, and this is the output from my test. I run my test and it says, oh, they both failed. This top one failed because of a singular matrix error because of the extra one. The bottom one failed because it's saying the answer should have been 2 and it gave me 1, right? It gave me the wrong answer in the case where there was because it didn't have an intercept in the model. When I went and asked Claude to generate tests, it gave me tests. They all passed. And basically what it did is it went in and realized the problems in the code, and it built the tests around those problems. So it didn't actually catch the problems. It basically learned that in those cases, it should ignore the problems or fix the problems in the test so that the test didn't pass. So this is, LLMs, it's hard sometimes not to kind of anthropomorphize the models, right? They've been trained to make people happy, right? After the model is pre-trained to produce the next token, they do a bunch of like reinforcement learning to basically make sure that it gives outputs that people like, that people say thumbs up to. And so it tends to follow what we call the happy path, right? Yeah.
Basically, trying to reverse the expectations.
Yeah, I didn't do that here, but I'll show you an example. That's part of my standard instructions now, sort of, is basically slightly different. Don't change the tests just to make them pass, right? But yeah, you could. It certainly would be able to do that. Yeah. So what are some failure modes of the AI generated tests, right? One is like modifying the test to pass the code, which that's one example. I've seen it do that in other cases. Because the models really don't like for the tests to fail. They'll do this. So there's a thing called mocking, which is like when you write a test, sometimes like, if you're writing a test that involves like going out and like getting something from a website, you may not want the test to actually like need access to the internet. So you can create like a mock version of the website that just gives back what the website would give back. what they'll sometimes do is create basically, like if they find something doesn't work, they'll create a mock implementation of the thing that works and then just use that for the test so that the test passes. Sometimes so an assertion we saw yesterday, an assertion is just when you say something should be true, right? This is commonly done in tests. What they'll often do is, or sometimes do at least, is basically have really weak assertions. So let's say that the function should give you back a number that's from 1 to infinity, or sorry, 0 to infinity, like a positive value or non-negative value. But the test might just check whether it gives back any value at all, right? Rather than checking whether the value is actually valid or correct. Sometimes the agents will just skip parts of the code for various reasons. Sometimes I think for kind of random reasons, just like falls out of the context. And then sometimes they'll fail to check for critical dependencies. And so I saw this in some code I was writing for the book, where there was a function I was using this. It was like this genomics analysis example I built. And one of the functions we were using, basically, if a particular module was installed, it would use that module. Otherwise, it would fall back and basically do nothing. And I told the code to write a test specifically for whether that thing was working or not. But what the test did was basically went in and said, if that module is installed, then actually check to make sure that the value matches what it should get with the module. If the module is not installed, just skip the test altogether. So it basically just didn't even really test what I was telling it to test for. So these are just a few of the ways in which the models can generate tests that are problematic. So I mentioned yesterday this idea of test-driven development. So the idea is like before you do anything else, you start writing tests that have to fail because there's no code yet. But the tests define what you want the code to do. They define the intended behavior. And so in some ways, the test is the definition of success, right? Once the tests all pass, then you're done. If you've written the test correctly, they should fully define all the behavior you want to see out of the code. Then you write just enough code to pass the test. And this prevents the models from, there's a thing that software engineers call gold plating, like basically doing things you don't really need to do just because they seem fun or cool. This will prevent the model from kind of gold plating the code. It'll just, you tell it, just solve the problem that you want it to solve. And then you can go and sort of do more stuff. But this turns out to work really well for coding agents. And one way that you can get it to do this is by instructing the agent in a particular way. So all of the agent tools now use these files, and there's various types of files. But all of the agents use something. The generic version is called agents.markdown, or for Claude, it would be claude.markdown. And these are files that include basically directions for the model on how to behave that are read in every time. Every time you run the model, it's going to read. The first thing it's going to do is read in these instructions. You can have instructions that live kind of on your whole system, like that live in your home directory, or you can have instructions for each particular project. This is an example from part of my claude.md file, right? So what I tell it, and you kind of have to yell at it, say non-negotiable. Write code that is clean and modular. Prefer shorter functions or methods over longer ones. And then I like to use UV for package management, so I tell it use UV for everything. One thing that a lot of Python people do that I really hate because it can make debugging really confusing is putting a bunch of code into these files called init.py files that live in in each kind of directory in a package. And so I basically say no code or imports in the init.py files. And then I have a bunch of stuff about testing, right? Use PyTest with a test-driven development approach. Prefer functions over classes for testing, use PyTest. These are just kind of details about testing. I have more about each of these in the book. Enforce the red-green refactor cycle with a test written first. Commit the tests before implementation, right? So that we can see that the tests are committed into Git before you ever start writing any code. Forbidden. You can't implement before the test. You can't skip the red phase. You have to write the test first. Forbidden. Changing the test simply in order to pass. All changes to test should reflect either a change in the requirements or an error in the test. forbidden, because this is another thing I've seen it do, simplifying the problem to pass the test. The test should fail for anything less than a solution to the full problem. What I've seen them do is basically create a really simple version of the problem that isn't actually the problem you want to solve and say, oh, hey, the test passes. So this is the way that I can get Claude to like make sure that it's actually behaving. Doesn't always, sometimes it'll ignore the instructions. They've gotten a lot better at it. I think like a year ago, Claude would regularly, it would start doing test-driven development and then it would get lost and kind of forget about it. That doesn't happen as much. Okay, domain knowledge, right? So you have to know in detail about the area that you're writing the code for, because the details are going to matter. And sometimes it can take a lot of expertise to figure out what's going on. So here's an example. This is from one of the problems we wrote in our first analyses. Write a Python program to determine the escape velocity from a celestial body given its mass and radius. And then that's just a bunch of boilerplate about how to give me the code back. So it gave me a function, this function called escape velocity. And here's an example where I'm testing it. I'm giving it the mass and radius of Jupiter. I'm giving it, put those into the function, I get the result back, and I check that result against the value that NASA tells me that I should get. And it fails. My code gives me back 60202. I was told I should get 59564 as the escape velocity for Jupiter. It turns out that both of those numbers are correct, depending on where you're standing on Jupiter, right? Because big planets like Jupiter are oblate, I think. They're not round, right? They're kind of like the radius differs at the equator versus the poles. And the fact sheet is this 59.5 is correct when you use an equatorial radius, right? The radius of the equator, but the value generated by the code is correct when you use the volumetric, the average radius across the whole planet, right? So they're both correct depending on where you're standing. I didn't even know this about planets. It makes sense, but I don't know much about planets. So it took me a little while to figure out why is this number wrong? So you kind of have to know something to interpret what's going on. LLMs are only as good as their training data. And so here's a problem that we discovered that's still a problem, or at least as of earlier this year, is still a problem. Generate a Python, this is the prompt we gave it. Generate a Python class that fits a hurdle regression model with a scikit-learn type interface. So hurdle regression is a statistical model for count data, like you're counting numbers of things that happen, but when those count data have a lot of zeros in them, we call them zero-inflated count data. And so the way that you're supposed to fit this model is you have you have your data, and then you have a model that combines the likelihood of a count model, like a sort of a Poisson model, with the likelihood of a binomial model, which is like a 0 versus 1 model, and you kind of jointly maximize those likelihoods. If you look on GitHub, there are a number of people who have posted Python code for doing hurdle regression. They all do it in the wrong way. They do it in a much simpler way where you fit a binomial model and then you fit a separate Poisson model on the ones that are not 0, which turns out not to be the right way to fit the model. And it gives you slightly wrong answers sometimes. It can give you really wrong answers. It always gives you at least slightly wrong answers. As of earlier this year, if you just went to all the models and asked them to generate hurdle regression, they will still give you that GitHub-based wrong answer. And I'm sure that's going to, well, maybe once it reads my book, it'll realize that it's getting it wrong and try to fix it. But as of earlier this year, if you went back to Claude and said, hey, that's the wrong implementation, here's the paper that defines the correct implementation, go implement this, then it could get it right. And you could test it against, there's an R version of that implementation, and you can actually test that it gets it right. So one of the ways that you can imbue domain expertise for coding agents is by giving them what have come to be called skills. So in the last year, again, just this stuff, I think I heard about them in December or January, right? This is like a really new sort of thing that was developed where it's basically just a bunch of files that you put into a directory called a skills directory that the model knows about, and if it encounters something that's relevant to the skill, then it can pull in all the information from the skill and use it, right? So you could, for example, have a skill on doing regression models that the description of the skill would say this is a skill to be used when generating a regression model. The agent knows about that, so whenever it has to generate a regression model, it would go pull in all the knowledge from that skill. And there's a ton of these things online. If you just go search around for agent skills, you'll find many thousands of them. A lot of them seem to be problematic. So you have to be really careful about it. I mean, it's kind of just like going and pulling random packages off of GitHub. You have to be careful, right? One, because we know that this analysis that I'm linking to down here showed that, a huge proportion of them, something like a third, had security issues of one sort or another. Some of them actually had prompt injection where it would try to do nefarious things. So you really have to vet them before installing them, either getting them from a group that you trust, or looking at in this Agent Man thing, they link to some places that review or provide kind of reviews on agents. Now, Claude Code is actually, and the other agents as well, are good at generating new skills, right? So if you have some domain that you want to work in, what I started doing here was trying to generate a set of skills based on our handbook of functional MRI data analysis. I haven't finished it yet, but kind of playing with it. But it turns out that the models can take if you have a set of papers or pieces of code, examples, things like that you want it to use to show kind of best practices for any kind of thing it's going to do, you can have it generate a skills file and then review that, make sure that it's doing what you want, and then that could be something you could include in your kind of basic skill set. And then anytime you go try to create code that's relevant, it'll pull in that knowledge. So it's basically a way of encoding domain knowledge. One skill thing that if you're using these models, you should absolutely try out. It may or may not work for you, but I found it to be really powerful. Is this thing called superpowers, which basically has a bunch of tools for kind of very basic software engineering stuff. So the brainstorming toolkit is basically like a planning skill. It has a code review skill that's really good. It has various other skills for doing test-driven development. And so if you go to the superpowers GitHub, it'll tell you how to install it. So what are some of the common failure modes for coding agents as of now, from what I've seen? Some of these, pretty much all of these have gotten better, but they all still happen on occasion. One is use of outdated APIs. So for example, it'll implement code, but it'll use an older version of the interface that no longer works with the newest version of the package. So they'll usually, if you go back and copy and paste the error that you're getting, it'll go look at the website for the package and say, oh, we're using the old version, here's the new version. So usually it can fix it. Incorrect implementation of algorithms like the herbal regression one that you saw. One thing that the agents will sometimes do is get stuck in these loops. I saw this once where it went on for hours. Basically, it was like a stupid web thing, and it couldn't get the website right, so it kept just trying different things, and then it would end up retrying the same things multiple times in slightly different ways, and never. Basically, I had to stop it. So you really have to watch the agent as it's working. You can't trust it to just go off and do its thing. You kind of have to watch it and make sure that it's staying on track and that it's not doing things in ways that you don't want. They still will kind of try to oversimplify the problem sometimes to solve an easy version and then declare success. That fits with this bottom, premature declaration of success. That's still a common problem. Gold plating, I mentioned, which is doing more than you need to do. And ignoring instructions, they've mostly gotten better at following instructions, but they still will sometimes kind of forget the instructions. So like I said, you need to be, if you're going to work with an agent, you can't just let it go and come back a few hours later and kind of trust that the code is going to be working. You really have to watch and make sure that it stays on track. And if you see that it's going off track, what you can do is sometimes just stop it and like, quit, clear the context out and start over. All these models all have a context function, like to clear the context. This is also a really important reason to use version control, right? Because if you're not checking into version control regularly, the model can go off and make a bunch of changes, and you might not be able to get back to the place where it was working, right? So it turns out that the models are really good at doing Git commits, and they're really good. So do you guys talk about merge failures at all?
Yeah.
Okay. So merge failures are like the bane of the Git user's existence, right? When you basically have some changes that have been made and you need to integrate them back into the old code, but the old code changed as well, and it's just a hairball. And I found that the coding agents are really good at actually solving those merge problems. But you need to basically make sure, and I should also have instructions. I don't like putting instructions to always use branches. Or always do stuff in Git, because sometimes I want it to just do things quickly. But in general, it's for any kind of like major undertakings. When you're using an agent, you want to be regularly checking things into Git so that you can always roll back if you find that the model is just blown up and you just start over. So AI tools have become really good at code review. At code review, I mentioned yesterday, is a really important thing to do. If you have good coders sitting next to you, that's a great way to do it. If you don't, then using LLMs is a really good way to do it. I had fun writing this chunk of code for a workshop I used to do on clean coding. It's basically intentionally bad Python code, which is kind of fun to try to write. And so I gave this was to Gemini. I said, please review this, identify the intended goal of the code and any anti-patterns present in the code. Anti-patterns are basically like worst practices, like bad things to do when you're coding. And this was intentionally written to have a lot of them. It says, this is a classic example of research code. But it nonetheless figured out exactly what the code was trying to do. And it went through, it identified some anti-patterns like that I had put in on purpose, like wildcard imports, which are really bad, or having imports all over the different parts of the code. Doing things this isn't so much like an error those aren't errors either, but like doing things in ways that are really inefficient, like in unpandas, like if you're using pandas, you shouldn't be doing loops, for example. And so I put things in to do that on purpose. It also found a mathematical error that I had intentionally put into the code where I'd called something BIC, which is a model selection statistic, but the computation, the formula that I used was actually for a different statistic. And it noticed that was wrong and told me that the name of the variable mismatched the thing that was being computed, right? That's a pretty good thing to catch. It also found something that I actually hadn't realized when I wrote the code, which was I was using factoranalysis.score to do I thought it was giving me back the sum of the log likelihoods, but it's actually giving me back the average. So my AIC computation was incorrect because that expects you to use the sum rather than the average. I didn't actually realize that score gave you the average rather than the sum. And so it caught something that even I had missed. Okay, so so I mentioned trust, right? When we write papers, we ultimately, I as a PI, you as a PI or a student, or wherever you are in your journey, have to basically say, I stand behind what I am saying in this paper, right? When you're an author on a paper, you're basically committing to that. And so you have to make sure that you can actually trust all the work that went into it, right? Before AI, this came down to like trusting the work of the students in the labs, the research assistants, your collaborators. Now it comes down to also trusting this robot, right, who's generating code for you. And so we need to think a lot about how we build in, what we call trust gates, right? Places where we kind of ensure that you can actually trust the results of the code. And I think this is a work in progress, and I'll be writing more about it in the book. And I think but I also I think testing is clearly the thing we have right now that all of us can do try to verify. Testing doesn't guarantee that the code works, right? Testing will show you where it's wrong. It can't tell you that it's right. But if you test it well enough, you can at least have some degree of confidence that it's doing the right thing. And, ultimately for each of us, our credibility is on the line. You're not going to be able to go back and say, well, that's the AI's fault, right? You have to take responsibility for the work if you're using AI. Just like you can't say, well, that was the research assistant's fault, right? If you're the author on the paper, you have to take responsibility for the work. I think, obviously everybody in my lab uses AI to write code now. I think we all should be using it to some degree, but we also have to be careful with it. And I think that vibe coding is not the way to think about it, right? Just letting the things go. Now, unfortunately, this is kind of what it feels like right now, right? Just, you're on this treadmill and kind of keeping up is really hard, but that's the way the world's working right now. And I think that we all are going to have to spend some time just kind of like, regularly checking in on our workflow to see how it's working. Cool. So I mentioned my book. I've been kind of serializing bits of the book every week, actually every day this week on my Substack. And we also have a paper that's in press at PLOS Computational Biology. Actually, the name changed a bit. It's now 12 quick tips for AI-assisted coding in science rather than 10 simple rules. But that'll be coming out shortly. There's a preprint up if you're interested. It overlaps a lot with what I said, just kind of thinking through some principles for for how to do good AI assisted coding in science. I'll put links to these in the Slack as well. So we have a few minutes for questions. Thanks.
So we have a question that came up in the chat. This person has heard that Claude and Anthropic are the best AI LLM out there with an emphasis on performance and ethics, which you haven't addressed very directly. Could you comment on that?
Yeah. They're all companies. It's hard to, you can slice about whether you think one is more ethical than another. And I think probably it is the case that Anthropic is maybe a little more ethical, but, ultimately they're about to be a public company, just like OpenAI is. And once something becomes a public company, they're beholden to their shareholders, not to anybody's ethics. Right. And so I think that, that we have to continually kind of question, whether we trust the people who are making the tools, right? Now, fortunately, we were talking about this earlier, there's an increasing number of open source or kind of open source-ish language models that have gotten a lot better. They're not as good as the frontier models from Anthropic or OpenAI, but for most problems, they're actually, like most coding problems, models like Kimi K2 or 2.5 or GLM 5.2 are pretty good. They're a lot cheaper than the commercial models. You can get access to them. So I mentioned a thing earlier called Open Router, which lets you basically have one interface to a bunch of different models, and they'll find the cheapest provider of those models. You can also run, like if you have a Mac, you can run kind of a decent model on your Mac. It's going to be slow. And your Mac is going to get really hot in your lap, but it works. You can kind of, like when I'm on an airplane, like I don't have access to the internet, I use like one of the Qwen models, and it's perfectly good if I need to ask questions about how do I do something in Pandas, because I've forgotten how to do everything in Pandas. But I wouldn't want to come out and say that one of them is like qualitatively more ethical than another, especially given their move towards becoming publicly traded companies. Yeah.
Do you trust like an enterprise model, like that's Claude Enterprise? Do you trust that more? Like if your school is like, or
yeah, because there's a legal arrangement there between your organization and the company that presumably, like I don't worry that much about Claude using my data for training, in part because everything I do is open source. It's going to be online anyway. I don't care if they use it for training, but for the most part, like if you're, I don't know what the agreements are for just like a standard Claude code thing. If you're using it via API, I think the agreement is that they don't use your data for training, for like model training. I think that's true even if you use it through the chat interface, but I'm not certain of that. Certainly there's an incognito version in Claude you can use. That's like if I have something that I don't want to get leaked out, I'll put that into like a private letter or something. I'll use the incognito version. I trust Claude well enough I trust Anthropic well enough that they're not going to be like, letting that out, which may be stupid of me, but, or I'll use a private model. But yeah, I think that certainly, if your organization has an agreement, then that's an added bit of protection. Yeah. Sorry, but I had bad hearing, so I have to come close to you.
Yeah, okay. You mentioned that everyone in your lab, to some degree, is using LLMs as part of their work, with coding. Have you found that your expectations for progress in whatever analysis you're running have changed due to the addition of LLMs, and that the time that you expect a task to take has decreased, and therefore
right.
I think, where I'm coming from is that I feel like I'm spending less time on each individual task, but then there's this sort of backlog that builds up in that making it finding it harder to take the time to review the code because it feels like, oh, I completed this, and now it's the pace has just increased.
Right. Yeah, that's a really good point. So let me just go back here to repeat the question for the folks on Zoom. So the question is basically, have my expectations about productivity and progress, pace of progress changed now that students in my lab use AI tools? And I think the short answer is maybe a little bit. My expectations about the quality of the code have definitely changed because the models, it used to be the case that people would give me like really badly, like, just ugly code. And that if you're writing code with the models, they generally are creating code that's, that is easier to read, that looks better. So my expectations there have changed a bit. I've tried not to. So here's what I'll say. I've seen some other graduate students, like in other labs who I collaborate with, who come with like just astounding amounts of code, right? Huge projects with like, 30 scripts that do all these like, analyses. And honestly, if somebody in my lab did that, it would kind of worry me, because I would worry about if they had generated it so quickly that I knew they didn't understand what all the code was doing. So that's why I certainly haven't, I haven't tried to push my students to accelerate their pace. I've tried to push them to like, make sure that their code is good. And so I think my expectations about like testing have gone up, in part because it's so easy to generate tests now. But then I have to ask the question, like, have you actually checked the tests to make sure that they're actually testing what you want? It's easy to generate a bunch of tests. It's harder to make sure that it's a lot more work to verify the test, right? So there's this, one of the fundamental kind of, quandaries here is this kind of like generation validation gap, right? Where it becomes really easy to generate code. The effort required to validate it basically remains the same, right? And so, as you say, it's really hard to kind of review all the code. And so I try to kind of shorten that loop. I don't want somebody to go generate, 4,000 lines of code and then say, oh, now I need to check it. I'd like to have that happening in a kind of a tighter loop. But it's hard to guarantee that, right? And the problem is that there's a lot of motivation in academia to get papers done quickly, and those papers need to have a lot of analyses in them. And, so the motivation, sorry, the incentives push towards all the worst possible outcomes, unfortunately. I've tried not to let my lab succumb to that, but I know a lot of labs are succumbing to it, and I hope mine won't. Yeah.
I was wondering your thoughts on, I guess, like ownership of knowledge. So like I think about like not that I'm an excellent coder or programmer, but I think about like when I learned that you're writing it by hand, for your exams in computer science, you're writing it by hand and handing it to the teacher. And at the end of the day, like that's something that like I can produce by myself, right? But I feel like it's very easy to ask these agents to do things that I couldn't organically produce, even maybe with tens, even if I spend a week on stuff or on like Stack Overflow trying to figure it out.
Right.
I was wondering, I guess, I don't know how much this is just like a moral question, but also on good practices with the thoughts around them.
Yeah. So the question is basically about ownership and knowledge, right? When like, what are the expectations and how do you ensure that people actually understand what they're doing? when all the code is being generated by models. And no, that's like the fundamental question that I think a lot of people are struggling with right now. And one challenge is that, like the companies are seeing, as I show you, the models are really only powerful in the hands of people who have deep knowledge of programming, right? It's really easy for things to go badly when you give like an entry level programmer access to these tools because they don't know how things can go wrong. The question is, how do you get to having that knowledge when you're not generating code by hand? We were having a discussion about this morning. I think one way that you can flip it is that the models are also really good at helping you learn stuff, right? You can say basically, hey, I want to learn about, how to write classes in Python. Can you quiz me and help me learn? And they can actually come up with like good ways to do that. In general, I think these models, like I had over the summer, I was going to do some expert testimony and needed to learn a bunch of new stuff and make sure that I knew it really well so that when the opposing counsel starts like cross-examining me, that I can answer the question. So I went back and forth with a number of chatbots and basically said, hey, here's my report. You are an opposing counsel, grill me as hard as you can. And they did a great job of like picking me, tearing me apart. When I was done with it, I really felt like I'd learned the stuff. And so I think they are really good learning tools if you use them the right way, but that takes time and effort, right? And again, I try to, I think my approach to graduate school is very different from other labs. Like a lot of labs think of grad school as like primarily about getting papers out the door. I think of grad school as about like learning how to do stuff and learning how to think. And that's why my students usually leave the lab without a ton of papers, which, isn't that great for them on the job market probably. But they feel like they really learn how to do stuff. And this is another challenge, it's kind of fast versus slow science, that I think we have to think about. Like, we're incentivizing all the wrong things when we basically, when the people who get jobs are the people with the 15 papers out of graduate school in glossy magazines, who may or may not actually understand, what the code was doing in their papers. But there are people working on that. We're part of a group called Helios, the Higher Education Leadership Initiative on Open Scholarship, which is basically trying to change incentives in academia broadly towards like more open and reproducible sorts of science, but it's just really hard.
So I think we're out of time for this session, but let's all thank Russ again.